Hello everyone, I am a tutor with UPlads and today we are going to learn about joins. In our previous lecture, we covered all the numeric functions, string functions, date functions, and we also covered a little bit of basic querying over a single table. But with joins, from today we are going to learn how to connect two different tables and give a single view. So let me first of all select star from uplads dot courses. So this is a presentation by uplads, and today's topic is joins in SQL. So you must have till now noticed that whatever we discussed or whatever query that we performed has been over a single table. But what in those cases where I want to retrieve data from two different tables? So in these cases, we would be using joins. This join clause, it is used to combine rows from two or more tables based on a related column between them. Okay. Now, what do I mean by related column? If you remember during ER diagram, I had mentioned something about association between two entities. Okay. A relation between two entities. So that's what I'm talking about. Then when you're talking about two tables, there has to be some common parameter in both the or some common column which is related to both the tables. Okay, so this join clause is used to combine rows from these two different tables, and it can be two or more tables. It is not restricted to two. You can join as many tables as you want based on a related column between them. Okay, so that was a basic idea you will get with joins. Now in joins also, we can come across different use cases. And based on that, we have to decide that which kind of join we will prefer to use. Okay, so in a generalized way, there are 6 important joins that are available. Inner join, left join, right join, full join, then there is self join, and we have union. I'm sorry, and we have cardinality. Okay, Cartesian product. Okay, why I talked about union, I'll come to that point soon. You will realize that. So these are different types of joins available in MySQL or any other platforms. And based on the use case or scenario we have, we need to make a choice between which kind of join do we prefer to perform. Okay, so to start with the inner join, just as the name says, wherever there is one common area, that is the inner area where records from both the tables match. So there are two tables, table 1 with let's say 10 records and table 2 let's say with 20 records. Okay, now there are some 7 records from table A that exactly matches that has got some information in table B, and both of them are related with a common column. Okay, let's say table 1 has a column ID and table 2 has a column A underscore ID. This ID and A underscore ID are nothing but the same parameter. Just that ID is probably the primary key of table 1 and A underscore ID is the foreign key for that table, table B. Okay, I'll demonstrate it to you. But please make a note that the inner join keyword selects all rows from both tables as long as there is a match between the columns. Okay, if there is no match, that row will not be retrieved. Okay, so let us check. If you remember that in our past lectures we created some tables. Okay, uplads dot users, then we had select star from uplads dot persons, and I have created one more table just so that I can demonstrate the joins use case to you guys. So that other table is uplads dot user occupation. Okay, now you can see that uh, there is one table users with 5 records, there is another table persons with again 6 records, and there is another table user occupation with 4 records. There are few common IDs, so all the 3 tables are related to each other based on this ID column. Okay, there is no difference, but they are all related to ID column. This is giving me some information, let's say manager and age information. for user ID 1, this table is giving me just the first name, last name information of the same user ID, and the other table, the third table, is just giving me idea of his occupation and salary. Okay, so now if you must have noticed, and if you remember, that in ER diagram I talked up something about normalization. Okay, now this table is ideally normalized. These three tables are ideally normalized because table 1 is holding just one type of information, table 2 is holding other type of information, table 3 is holding third type of information. Had it been the case that all these three different informations are stored in a single table, we call those tables as unnormalized. Okay, what we need to do is we need to normalize these tables and maintain it, and that's where that ER diagram comes into the picture. Probably now you will be able to better visualize what I had said back then. So these are three tables. ID is the common relation between them. Let us start with our demonstration for inner join. Okay, so now let's say I want to retrieve uh, the IDs from table A and their occupation and salary. Okay, so I want all this data plus I want the occupation and salary for these IDs. Okay, and I want it for those who have some occupation, only those records I want. Okay, so what I will do here is select, first of all let me write from clause for you, uplads.users A, join it with, if you mention inner join it is fine, if you don't mention inner keyword that is also fine, it is by default taken as inner join itself. Okay, so if you write inner that is also fine, if you don't write inner that is also fine. Okay, that I have to join with my user occupation table B. Okay, now these are the aliases I have given. So now I should understand there is a possibility that both the tables could have some common parameters in it, right? Just as we have ID here in this case. So I need to give an alias so I can do proper selection of my columns. Okay, and also to mention the conditions. Now, remember, whenever I'm using join condition, there has to be an on clause. Okay, I'll tell you what happens when you're using join but you're not using on condition. I'll also demonstrate that to you. But before that, it is mandatory that whenever join clause is written, there should be some on clause for it. Okay. Now the on condition comprises of a condition that is commonly related to both the tables. In our case, it is ID. So I will write something like this. Okay. So what I've done is I've joined these two tables entirely on ID column. Okay, and now what I want to do is I want to retrieve some data from table A and some data from table B. Let's say from table A I want everything, but from B table also I want everything, but ID I have already retrieved, so I don't want to repeat that. So I'll explicitly mention the columns that I need to retrieve. Okay, yeah, so this is it. Let us check the output. Okay, I'm sorry, that is not age, that is salary. So let me replace age with salary. Okay, yeah. So this is the output of the inner join that we have just run. Okay. Now what difference do you see is that wherever there is a match, going back to the definition which I had given, it will select all the rows from both the tables as long as there is a match between the columns. Okay. So there was a match for ID equal to 1. If you can see, there was an match for ID equal to 2. 3 and 4 were present in table A, but there was no matching record in table B. Okay, so we did not retrieve that in our final output. Now there was a match for ID 5 as well, so we retrieved that row. There was no row for ID equal to 13 in table A, but there was one row for ID equal to 13 in table B. But since it is not a match, we will not retrieve that. Okay, so only data for 1, 2 and 5 was retrieved, as only these three IDs have a matching record in both the tables. Okay, and as per our select condition, we have retrieved everything from table A, and we have retrieved occupation and salary of those users of the same ID from table B. So if you can see that table ID, it has ABC 102 as name, age, and manager ID respectively. And the occupation of user ID, user ID 1 was software engineer, and 72,000 was the salary. So that's what we can see here. Okay, so that was inner join, where it will select all the rows from both the tables as long as there is a match between the columns. Okay, moving on to next. This was simple. Also, I told you that if you write inner join, it is still fine. If you don't write, it is still fine. If you don't mention anything here, the default assumption that the SQL makes is that instead of join, it will assume it is inner join. Okay. So if you are thinking that you'll just mention join and you expect it to work as a left join, then it will not be the case, because if you are mentioning join, the default that SQL understands is inner join. Okay, so that was inner join. Next, what we have is a left join with us. Okay, now we talked about inner join, that is matching records from both the tables. But what in those cases where I want to retrieve all the records from table A, but I only want to retrieve the matching records from table B? Okay, so what we will do is we'll use left join here. Let me demonstrate it to you. First of all, let me again show you the raw tables. uplads.users, and select star from, where am I writing? Okay, from uplads dot user occupation. Okay, now let's say I want to retrieve all the rows from users table but only matching records from B table. Okay, I cannot perform inner join. If I perform inner join, you have already seen that I lose out on data for 3 and 4, id equal to 3 and 4, because there is no matching record in table B. Okay, so what I will do is select A dot star comma B dot occupation comma B dot salary from I'll take the table A here first of all, from which I want to retrieve all the records. So from users I want to retrieve all the records, so that will be the first table. Then I will write down the left join clause here. I have to mention the left word keyword here. Okay, this I want to match the records with the B table, that is user occupation, and the joining condition for both will remain the same, that is on ID equal to ID B dot ID. Okay, so now when I do this, what I've basically done is from my previous query, I've used the same query. Instead of inner, I have replaced that with left join. Okay, let us see what happens in that case. As you can see that I have retrieved all the records from table A, that is from first table, that is present on the left side of the join clause. Okay, that comes first in the query. So that I have retrieved all the records from that table. And if you see that for 3 and 4, which previously was not even retrieved, we have derived null values there because the entry is not there. There is no match on ID column. Okay, that is why we have retrieved null for ID equal to 3 and 4 as the data is not present. Also, 13 is present in the right table. Okay, that is in the right side table. But what we have used is left join. So it will retrieve only all records from left table. So if you expect that in left join, whichever new record is present should be in my table, then that is not the case. If you want to see 13 to be added here, then you need to use the right join. Okay, because you want records, all records from right table. Okay, we will demonstrate that as well. But for now, what left join has done is it has retrieved all the records from the left table, that is the first table coming in the query, and it has given me the matching records from table B, or else it has given me null for the non-matching records. Okay, so that was left join for you. Also, note one thing, that this left join is nothing but left outer join. As you know that there is inner join, there should definitely be an outer join. Inner join is all matches. Left outer join is few matches and few unmatches. Okay, so left join works as left outer join itself because it is retrieving the rows for which there is no matching record in the other table. Okay, So if you write left outer join, that is fine. If you don't write left outer and you just mention left join, that is also fine. Okay. So that was left join for you, where it returns all records from the left table and the matched records from the right table. And for the unmatched records, it will retrieve null. Okay. Right join or right outer join exactly works exactly opposite of left join or left outer join. It returns all records from the right table and the matched records from the left table. Okay. Let us demonstrate this. So now if let's say if you wish to see all the rows from table B and the subsequent age and manager ID for these records. Okay. So what we will do is select from, everything will remain the same as left join. Only thing is that instead of left, I will change it to right. Okay. Now what I want to do is I want to retrieve all the records from right table. Okay. That is from user occupation. So I will simply write b dot star because I want all the records from my right table and all the columns from my right table. But from A table, I want only manager ID and age. Okay. So I will write a dot age, comma a dot manager ID. Okay. So when I do this, you can see I've retrieved 4 records and those 4 record IDs are 1, 2, 5 and 13, which is exactly matching with my user occupation table, which is present in the right side of my right join. Okay. 1, 2, 5 and 13. And for those IDs, I have retrieved the age and manager ID from left table. Okay, for 1, 2, 5 and 13. For 13, nothing is present. Okay, there is no row for 13. So it will give me null as age and null for manager ID. And that's what we have retrieved. Okay. Now you must be wondering that for 5, why did we get manager ID null? We have a matching record in left table. That is because in the original table itself, we have a null value. That is why we have retrieved null in the final view as well. Okay. So this is what the right join works. This is how right join works. Now, there is one more trick you can use. You can use left join and perform right join on it. How you can do that is simply you have to swap the table ordering. Okay. So it will look something like this. Left join and then users. Okay. So what I've done is basically same left join query I have used. It's just that I have swapped my table orders. I have taken right table to the left and left table to the right. Okay. I want to demonstrate that how will I perform right join using a left join clause. Okay. Now also make sure that you have changed the table ordering. So your final select column structure will also change. Since A is user occupation now, let's say I want to retrieve all the records from table A. So A dot star, comma, B dot age, comma, B dot manager ID. Okay. If I run this, you can see that the final answer that I have got matches exactly with my right join. Okay. So right join gave me one view, one final view, which has matched exactly with the left join, which I have manipulated to work as right join. Okay. So that is how you can make use of joins, understand what use case is you have to deal with, and accordingly make the right choice of using which join you want to perform. Now this was about left outer join. There is one more important join which is generally used, full outer join. What it does is returns all records when there is a match in either left or right table. So now when we are talking about or condition, either left or right, so we are talking about union. Okay. Union is always related to or clause, while intersection is always related to and clause. This intersection and clause is nothing but inner join. Okay. So remember this tip. You might need it for some logical use cases. Intersection and clause, inner join, they go hand in hand. Okay. While union or and full join or full outer join, They go hand in hand. Okay, remember this tip for sure, because this might be useful here or in some other, probably in building some ER diagram, you might think of it. Okay, so now we'll talk about full outer join. Before we talk about full join, let me tell you that full outer join, this full join is keyword is not supported by MySQL. Okay, I'll demonstrate it to you that how we can see it in our final view, but it is not supported by MySQL directly. Okay, first of all, what does this full outer join do? This full outer join keyword, it returns all records when there is a match in left or right table records. Okay, that means we are performing a union of left table and right table. Okay, union of left join and right join. That is what is full outer join. Okay, now also make a note that this full outer join, it can potentially return very large result sets. Why? Because it is obviously an OR condition. So let's say you have 100 different records in table 1 and 100 different records in table 2. This is going to return me 200 rows. Okay, that means the size of my data set has now increased. So be very careful when you are dealing with big data problems, because in big data problems, you already are dealing with millions and trillions of records. And in that, we are performing full outer join. So those millions and trillions will be completely doubled up. Okay. And the operation will become very heavy for you guys to perform. So be very careful that where and in which use cases you are using full outer join, or just make a right choice of joins that you are using, because it also query is just not writing down queries and retrieving data. It is also about writing optimal queries and getting the data in a faster speed, at a faster speed. Okay. So just be careful, because this full outer join can return very large result sets. Okay. Unless and until it is mandatory for you to do, I would suggest I would recommend not to use it. Now, let me show you that how exactly does this output of full outer join looks like. Full outer join is not supported by my SQL, but I will demonstrate it. We'll use a definition. Full join means it is a union of left join and right join. So that is what I'm going to write in my query. Okay. So select A dot star, comma B dot occupation, comma B dot select. Okay. From uplads.users table join, sorry, it is a left join first with uplads dot user occupation b on a dot id equal to b dot id. Okay, this has become, we have performed a left join here. Okay, now we want to perform a right join. Okay, so let me first give you an output of this. Okay, now what we'll do is we'll perform a right join. Okay, now you can see that in both the tables, there are few exactly matching records. So if you look at ID equal to 1, it is present in both the results. ID equal to 2 is present in both the results. Okay. And ID equal to 5 is also present in both the records. So these three are basically going to be redundant if I directly use union all. Okay. So now what I will do is select, then I will perform a union. I'll tell you why I have performed union here. Okay, and then we have this. Okay, now you can see that record number 1, 2, 5 are not repeated. It is simply there is one record for ID equal to 1, there is one record for ID equal to 2, and same for ID equal to 5. Now I used union because what union does is it removes duplicate columns from your final view. If I want to see duplicate rows, if that is my wish, then I will write down something like this, union all. Okay. Now you can see that there is a repetitive row for ID equal to 1, ID equal to 2, ID equal to 5. Same is being repeated again. Okay. This is what the difference is between union and union all. Okay, union will take care of duplicates. Union all will take all the records. It will not look at it whether it is a duplicate thing or not. Okay, though union all is faster operation wise because it is not performing an additional check of removing the duplicates, while union is little bit expensive than union all performance wise, because it has to check the duplicate records, filter out that as well. Okay, but it is always optimum way to use union. So between a trade-off of expensive clauses or expensive SQL commands and storage, you have to always make a trade-off between these two elements. Now here we are saving the storage space. I'm getting rid of redundant data, so I will go for the expensive command than giving up on my memory and using union all. Okay, so basically now what you see here is this is the output of full join or full outer join. Full outer join does just as I told you, it is a union of left join and right join. So there are three operations that full outer join performs. One is that it will first retrieve records from left table which has no matching records from right table. Then in second set, it will retrieve those records which are present on both the tables, in both the tables. And in third set, it will have only those records which are present in the right table, but no record is found in the left table. Okay. And it will do a union for all these three subsets. And that is how the output of your full outer join will look like. Okay. This is just an alternative approach of writing full outer join. It is basically, as I told you, definition wise, it is union of left join and right join. Okay, and make sure that you are using union and not union all, because I have already told you the difference between them. Union handles duplicate records, while union all does not care about duplicate or redundancy. It simply retrieves records from both the tables, from both the sides of the both the queries. Okay, so that was full join. Now coming to next is the self join. Okay, now what is the self join? Okay, self join is just similar to, in fact, it is exactly same as inner join. The performance and the functioning of this join is exactly same as the inner join. The only difference is that the joining is with itself. Okay, so in inner join there was a different table A and then there was a different table B, and there was some joining condition between these two tables. But in self join, what we have is we have table A and we have table A, and there is common ID between them, and we will perform a self join. Where is this being used? I'll demonstrate that, you will understand it better with example. So select star from uplads dot users, if I say, okay, so now I have 5 records here. For every ID, consider this to be your employee table. Okay, now employee 1 is reporting to manager ID 2. So manager for ID 1 is 2. But how do I understand that who is 2? I need to have some name in my table, right? So what I will do is I will perform a self join in this case, because this manager ID 2, even manager is part of employee table, right? Even manager is an employee. So even though my 1 is reporting to 2, there should be some record for 2 in our table. So 2 is also a manager, right? So basically ABC is reporting to 2, that is to manager PQR. So ABC is reporting to PQR. I want this in a single row. Okay. Right now I can make an understanding that 1 is reporting to 2 and the name against 2 is PQR, because I just have 5 records here. But in those cases where you have a huge amount of data, in big data especially, okay, in those cases you cannot sit and manually identify who is reporting to whom. In such cases, we will go ahead and use self join. Okay, let me write down the query for you. So I want all the columns from table A and from table B, that is again the self table. I just want one extra column, That is the name of the manager ID. So I will simply retrieve name from b dot table as manager name from uplads dot users a join or inner join, whatever you are comfortable mentioning, uplads dot users again because it is a self join, and the joining condition will be a dot id equal to b dot id. Okay, if I run this, you can now see that only one extra column is added to the final view. So 2 is basically oh, I'm sorry, good, I did this mistake. Let me tell you what is wrong with this table. Okay, what is wrong with this query. Now what it has done is I made a join from ID and I made a join to another ID. Okay, so now what has happened here is it has checked for this ID and it has matched it with the ID column of same table. Okay, so you could see that I have the joining condition that I have mentioned is wrong. Okay, what it did was from table A ID, it has again tried to map this ID with the table B ID. Okay, so it got name as ABC. What I want to do is my join should have been on manager ID. Okay, so if I make the changes, just one I. Okay, now you will see that I have exactly got the data for my records. But also let me tell you, now we have performed inner join, so there has to be some mismatch because only matched records are being retrieved. Okay, so uplads dot users I have. Okay, so now what you can see that there are only 4 managers present in this table. Okay, 2 3 4 5. For null there is no record. Null is no manager because probably 5 employee 5 is the CEO who is reporting to nobody. Okay, so we got only matches for 2 3 4 in the, let me also, okay, now it will be better. This is table A and then this is table B. Okay, now for manager ID 2 is part of this table and the name is PQR. 3 I got a match from the table and the name is uplats. For 4 also I got a match and the name is again uplats. For 5 I got a match in the table B, which is, and the name for the same is SQL. Okay, so you can see that I retrieved 4 records here. But for ID equal to 5, the manager ID is null. That means 5 is reporting to nobody. And for null, you can see that I have already told you so many times in our lecture before that null is not it cannot be compared with any other value because null itself is not a value, so it cannot be compared. So when you try to join null with anything else or you try to compare null with anything else, it will return null. So that is no match at all. So that row number 5 will not be retrieved in our final view. Okay, what if you wish to see row number 5 there but with manager ID and manager name as null? Then nothing, we will just make a small change to our query. Before join I will go and write left join. So it is basically left self join. So whatever joins we discussed, left join, right join, full join, everything is possible. If everything is being performed with the self table, then they become self join. Okay, so now you can see that I've retrieved data for ID equal to 5 and my manager ID and manager name is null because no matching record was found for that employee. Okay, so that was about self join. Next is the Cartesian product. Okay, what exactly is this Cartesian product? It's very easy to understand. If I perform, I told you before that if you give join, if you mention join clause but you don't give any condition, okay, see what you get. You get 25 records, and what has happened in cross join is that every record is being matched with every other record in table B. Okay, so if there are 5 rows in table 1, if there are 5 rows in table B, then the first row is matched with all the 5 rows of table B. Then second row of table A is matched with all 5 rows of table B. Okay, so basically it is m into n you will get. That is 5 into 5, you get 25 records in all. Okay, so now this one is even more expensive to use than full outer join, because in full outer join at least you are getting some matches and you will get only 200 records. But in those cases, in if there was 100 record in table A, if there were 100 records in table B, you will get 200 output result set for in cases of full outer join. But if you are using cross join, then in that case you will get 100 into 100, that is 10,000 records, which is not very easy to process. Okay, 10,000 is still fine, but when you're dealing with millions, trillions of data, then it becomes very difficult for operating such huge data. Okay, so that was cross product for you. And with cross product, we complete our joins. Now we are comfortable in few domains. We know different functions of SQL. We know the basics of databases, like how exactly every command functions in the database. We know about that. We also learned about querying from two or more than two different tables. Okay, we can query that way. We covered subquery as well in our previous video lectures. So thank you for your patience. Thank you from you, Plats. In our next lecture, we will cover small part of SQL, which will be helpful for you in automating things. Right now, everything I had to write, nothing was automated. In our next lecture, we will cover stored procedures. We will cover functions. We'll try to understand what views are. Okay, so this will be helpful for automation purposes in SQL. Thank you.